So as we ended that last video, we realized we need technology to get exact probabilities out because the empirical rule is limiting, and even when you can use it, it's only giving you an estimate and not an exact value. So what we're going to look at are these cases where we're looking for probabilities. So we'll have some normal distribution, we'll have some mean and standard deviation. So that means they're giving us this whole structure of normally distributed with some mean and some standard deviation. So we'll have some bell-shaped curve to work with. And then what we want to do is find probability. And when we want to find probability, they're going to give us some cutoff values. So the cutoff values, that's what's going to begin and end the area that we're searching for. So again, probability with these normal models is going to be represented by area under the curve. So that area is going to have to begin and end somewhere, and that's what the cutoff values represent. So what we're going to do is go to Geogebra. So in Geogebra, when we go to the website here, so geogebra.org, what we're going to do is go to more apps, and this is going to be similar steps to what we did for binomial calculations. So what we'll do is go down to probability. And what's nice is that it automatically opens on the bell-shaped curve. So with binomial, we had to go to this drop-down menu and change form, but we don't need to with this. So you'll just go to Geogebra and choose probability, and it'll all be set up for you. Now, when you open up the bell-shaped curve, it's always going to start with this mean of 0, standard deviation of 1. This is called the standard normal distribution, and we'll talk about this more in the later video. So what we want to do is they'll be telling us some mean and standard deviation for our data. So our first step is to edit those. So the first thing you're going to want to do is type in the values for your mean and standard deviation. So what we're going to do is continue that example that we were working on the previous video, and we're going to improve those estimates that we got out. So what we want to do is use that normal distribution for Portland rainfall, mean of 40, standard deviation of 8. So in GeoGebra, what I would do is go to the mean, type in 40, standard deviation, type in 8, and then we can see our number line. Now, with our number line, unfortunately, GeoGebra doesn't mark exactly the standard deviations. Like in my hand drawing in the previous video, I had 48, and it is in the same spot. Like 48 is about right there. But here, the tick marks aren't landing a certain number of standard deviations away. So just be careful that when I'm drawing by hand is slightly different in terms of what numbers are showing up. But the scale is the same in terms of like between 32 and 48, high probabilities. And by the time we get out to 64, we're way out in the tail here. So that scale is here. The numbers showing up are just different. All right, so what we want to do is find area under the curve. Now with binomial, I showed you how you could kind of drag and drop here. And that worked great for binomial, where it was kind of clear, discrete cases. I highly recommend not doing that for these, because you'll see these decimals showing up for our cutoffs. Like if I wanted to have exactly 32, it's very hard to get there, and maybe even 31 might be near impossible. It's better to type. So that's what we're going to practice in this video, is what to type in there to get our values. So that brings us to the next piece. With our question, we'll have to choose a direction, just like we did with binomial, and it'll just depend on the question that we're working on. So again, this symbol for left-sided, that'll work great for less than, or those questions where you want to look at most some value. And again, less than or equal are the same thing under the normal model. So if it just says less than or equal, we use that symbol. Then we'll have the symbol for between two values, and then we'll have the symbol for greater than or equal to, or other wording that we look at is at least some value. So you want to choose a direction for the area of the curve. So we'll just need to adjust in there. And again, I love GeoGebra because of its visual aspect, so that if you know you want less than, you can see it's shading to the left, to the right, or between two values. Then from there, we need to edit. So in this section where we're finding area, we are going to edit this part. So that'll be our step 3, is to edit the cutoffs. So we'll plug in our cutoff values there, so that it will be telling it where to have that area begin and end. Now there's 2 places to edit here because it's doing area between, but as you'll see, if you want like left-sided, you only need to plug in that cutoff there for where you want the area to end. So having less than some number, you'll just type in that number you want less than. Or area to the right, where you're looking at more than some number, you'll type in that number that you want to have more than. And then your solution comes out over here. That'll be where your answer shows up. So that number that's showing up on the other side of the equal sign represents a probability that will change to a percentage when we write our sentence answers. So go to probability, plug in your mean and standard deviation, set the direction, set the cutoff, and then get your probability out. So let's revisit those examples we looked at in our first video. So in part A, that's where we wanted to look at between 32 and 48. So in terms of notation, between two values, so between 32 and 48. Again, in this section, all of my inequalities are going to have the equality part of it just to match with what you're seeing in GeoGebra. So looking between two values, we'll plug that in. This is automatically going to one standard deviation below and above, but if you just imagine that we had different numbers, you could go here and type in the number you wanted, go here and type in that upper bound that you wanted. And just like with binomial, the little tip that I gave, same thing here. Once you finish typing in, just be sure to hit enter so things adjust correctly, because sometimes you can type and it doesn't actually change yet until you hit enter. So we see this 0.6827. 0.6827, which makes sense and shows that the empirical rule was a good estimate, because what we got in that last video was about 68%, but now we don't have to say about anything. This is just a 68.27% chance that they have rainfall between 32 and 48 inches. Part B, we looked at the probability of more than 48 inches. So I'm looking for the probability of more than or equal to 48. Again, even though it's saying more than, we get to just use more than or equal to because there isn't a difference in probability there. So more than. So I want area to the right, and I want this cutoff to be 48. So I'm going to edit the cutoff value of 48 and hit enter, and we have a 0.1587, which again, our estimate with the empirical rule was close. We had about 16%, but this is the exact correct value. This is the value that we want coming from GeoGebra. Part C, we looked at the probability of less than 24. So less than or equal to 24. So this will be a left-sided probability. So I'm going to set area to the left, and I'll go ahead and type in my value of 24. And what's nice, I don't have to edit the mean and standard deviation each time. Since I'm using the same bell-shaped curve, you can just leave that be if it's all tied to the same question. So I left-sided, cut off a 24, and we get a 0.0228, which is nice and close to that 2.5% that we estimated with the empirical rule. This would be our exact value. And then now we can answer part D, that 54 inches or less. So with the empirical rule, we were stuck because it wasn't landing exactly a certain number of standard deviations away. All we could see is from that picture that I made in that last video is we shaded a large area, so I'd expect a really high probability coming out from this. But other than that, we couldn't get anything numerical out. So now what we can do is in Geogebra, this was left-sided, so I'm in that left-sided mode, and then all I have to do is type it in. So this is where you can plug in absolutely anything into Geogebra, and it'll find that probability for you, which in this case is a 0.9599, which makes sense because that large area has a high probability. I'm just gonna double check that I hit enter there to make sure to adjust it correctly. Okay, just in case. Awesome. So that's an example with the rainfall and kind of finishing up what we saw with the empirical rule, but making it better. Let's look at a totally different scenario just for a little bit of practice. So here they're looking at cholesterol levels of children in Wisconsin, and what they tell us is that it is normally distributed. So with that, I know the shape. So if we're going to draw a picture here, so if I draw a picture, we have a bell-shaped curve. We just draw that as best we can. And then they tell us about the mean and standard deviation. So with those two pieces of information, I can get a number line going. So mean, I'm just going to draw that close to the middle there. Standard deviation, it's about 1 standard deviation away. When I ask you to draw a model, typically go to standard deviations above and below. So fill out 5 numbers for your number line. You can go to 3 standard deviations, and that's totally fine, but most of our work will be focused in this kind of 2 standard deviation area. So this model, how we could define it is our variable x, which in this case is representing the cholesterol levels, is normally distributed, so you can use that value of n, and mean of 1.75, standard deviation of 0.3. So you can put our number line together. 1.75 is going to go in the middle there. If I add 0.3, that'll be a 2.05. If I add 0.3 again, 2.35. And then moving below, this will be 1.45, and moving below again, 1.15. So I can see a scale for my numbers there and the values I expect to come through. So in part B, we have a child has a cholesterol level of 2.11, and we want to see what is the percentage. So again, if they ask you a question about percentage or probability, you're thinking about finding area under the curve. So we want to find area under the curve who have cholesterol levels that are higher. So what I want to do is 2.11 is going to be my cutoff. So just to draw a sketch up here, 2.11 is maybe there-ish. It's definitely between 2.05 and 2.35. And then I want the probability being higher than that value. So that value or higher is going to send me to this right-hand side. So I want to find this probability that our variable is more than or equal to 2.11. So with that, we're going to go to Geogebra. So I'm working with a different scenario here. So first thing I need to do is set my mean. So we have a mean of 1.75, standard deviation of 0.3, and I want to find an area to the right. So I'm going to change this to the right-sided mode, and our cutoff is 2.11. So then I could see and just make sure the picture matches up with the question that's being asked. I have the right scale along the number line there, and we're at 2.11 and want the area to the right, which is 0.1151. So we found that probability, and as always, make a nice sentence answer with your conclusion. So we could say, they asked what percentage of children, so we could say 11.51% of children in Wisconsin have cholesterol levels higher than 2.11 milligrams per milliliter. And that will do it. All right, one more question here of find the percentage. So we want to find area under the curve of children in Wisconsin who have cholesterol levels between. So we're going to look between two values, and they're giving us a lower bound and upper bound. So what this will look like, and I'll just kind of draw over what we did here. 1.3 is maybe about there, and 2.23 is maybe about there, and we want the area in between. So we want this total area between those two values. So what I want to find in terms of notation, start at 1.3 is less than or equal to x is less than or equal to 2.23. So then we'll go to GeoGebra. I have my mean and standard deviation set up. I'm going to change to the interval notation, and then I'll just set my lower bound and upper bound. So 1.3, 2.23, enter, and that's a 0.8784, which makes sense. It's a high probability because we're shading a lot of area under that curve there. So 0.8784. So you could say 87.84% of children in Wisconsin have cholesterol levels between 1.3 and 2.23 milligrams per milliliter. So this is how we'll go about finding probabilities with our normal distribution, given some cutoff value and given some direction of less than or more than or between. Go to GeoGebra, plug in those cutoffs, and grab our answer.